Right, it's time to put together the stuff we've been talking about and actually factor some of these larger degree or higher degree polynomials. I'm going to start with this polynomial here, and we're going to use synthetic division to try to identify the zeros of the function, which means I have to pick some numbers to put in to check to see if I get a zero for a remainder. When I get a zero for a remainder, I found a zero of the function, which gives me a factor of the function. Now, what numbers am I going to try? Well, remember the possible rational root theorem says that if a number is going to work, it's going to be a factor of the 8 of the constant divided by a factor of 1. So factor of 1 in the denominator is going to give me all whole numbers. There's not going to be any division here. And the factors of 8 are 1, 2, 4, and 8, positive and negative. So let's try putting in, say, 1. I'm going to do this in pencil because it is a trial and error, so I don't want to have to rewrite everything. I want to be able to erase. If I put in 1, I get 1 times 1 plus 4 is 5. 1 times 5. I'm going to subtract 3, or negative 3 plus 5 is 2. 1 times 2 is 2. Negative 14 plus 2 is negative 12. Times 1 is negative 8. Sorry, times 1 is negative 12, which with negative 8 is going to give me a 20 there. That's not a 0, so 1 is not going to work. So I'm going to get rid of all that good stuff there. And I can kind of cross 1 off my list, but negative 1 might still work. So let's try negative 1. Bring down the 1. Negative 1 times 1 is negative 1. 4 minus 1, 3. Negative times 3 is negative 3, which gives us negative 6, which gives us positive 6, which gives us negative 8. Negative 1 times negative 8 is positive 8, and that gives me my 0. Okay, I get a remainder of 0. That means that x minus this, so x minus negative 1 or x plus 1 is a factor of this. And the other factor comes from right here. We had a 4th degree, so this will be a 3rd degree. We have x cubed plus 3x squared minus 6x minus 8. All right, so we factored one factor out. Let's look for more. We don't have to worry about this anymore. We haven't gotten rid of it. We factored this into this, which means that now we need to worry about factoring this factor out. So 1x cubed, 3x squared, 6x minus 8. And what numbers do we need to try? Same ones as before, because we still have our 8 there. So I'm going to try that negative 1 again. Bring down the 1 times negative 1. 2 times negative 1. Negative 6 minus 2 is negative 8. Times negative 1 is positive 8. 0 again. Okay, so I still have my factor of x plus 1. Now I've got another factor of x plus 1 and another factor of x squared plus 2x minus 8. Well, that one I can factor by hand. I could use synthetic division again to test some more numbers, but I don't need to, because I know this has to come from x and x. And here I need two numbers that multiply to be 8, that subtract to be 2. So that's going to be 4 and 2. If I want that middle term to be a positive 2x, it's got to be a plus 4 and a minus 2. So now I've got a polynomial all factored out. And between, this is the next topic, or the next section, but between this form and what it tells me about the graph of the polynomial, and what this form tells me, right? This one gives me the end behavior, the number of turning points, the number of x-intercepts, and the y-intercept. This one gives me all the information about the x-intercepts. Between the two of them, I can totally graph this function. Now let's do one more. Let's go a little long on this one. We've got x cubed plus 9x squared plus 14x minus 24 here. which means the numbers I'm going to have to try are going to be factors of 24. Again, no fractions because there's no number here. It's just a 1. The factors of 24 are positive and negative 1, 2, 3, 4, 6, 8, 12, and 24. Now I can pretty much guarantee you the 8, the 12, and the 24 aren't going to work. So you can concentrate on these numbers here. But I want to show you, not a trick, I want to show you a strategy here. Before you even start, use your technology. Right? Clear that out. We've got x to the third plus 9x squared plus 14x, 14x minus 24. If I graph this, where does it look like it's crossing the x-axis? It looks to me like it's crossing the x-axis at 1, -4, and -6. So I'm thinking those are the numbers I want to try. 1 and the 4 and the 6. Use your technology to give you an advantage, to help you start in the right direction. Set up my synthetic division, 1, 9, 14, -24. And I'm going to put in 1. 1, 1, 10, 10, 24, 24. Multiplying by 1 is real easy. 0. Good, got it. So now I've got a factor of x minus 1 and my other factor of x squared plus 10x plus 24. Okay, that's what this right here represents. This gives us the x minus 1. This gives us the other factor. Now we can, if we want to, we can set up a new synthetic division here just by taking these numbers, as the numbers across the top from that polynomial. And then what else did we say worked? -4? Let's do -4. 1, -4, 10 minus 4 is 6, times -4 is -24, and that gives me my 0 there. Okay, so now our factors are x minus 1 from there, x minus 4 from there, x plus 4, right? Change the sign. And then this factor right here is x plus 6. That's our remaining factor. Now, if you want to test this in your calculator, go ahead and graph this guy here and also graph this. And the graphs should be the same. They should follow right along each other. So you won't even see the second one graph. It'll look exactly like the first. All right, we're going to do a couple more of these in the next video, and then we'll move on.